Hello, welcome. All right, so in today's video, we'll try to look at circle theorem properties, and this was requested by 3 of my subscribers. So I'll show you their names, and here are their names. You can check what they requested for. So now, under circle theorem, there are some things that we need to understand as we are working out questions. So, number one thing that we need to know is that angle in a straight line is 180 degrees, and in a triangle, so like this is a straight line, so the angle which is here 180 degrees. This is what they mean. So the angle from here to here is 180 degrees. So if you're dealing with a straight line, just know that it has got an angle of 180 degrees. Okay, let's check another one. The triangle they've talked about, the angles inside add up to 180. So the angle which is here plus this here plus the angle which is here supposed to give you 180 degrees. Let's say this is the angle Z, this is angle Y, and this is angle X. So when we say angle Y plus Z plus X, it's supposed to give you 180 degrees. This is what this statement means. So let's try to go to another one. Inside here, over here, this is a quadrilateral. So the angle which is here, 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 and here, when you add them up, they are supposed to give you 360. What we mean, if this is Z, X, Y, and angle K here. So if you say Y, angle Y plus X plus K plus Z, they are supposed to give you 360 degrees. This is very important. Let's also know something. We need to know what this means. This is a chord. So this is a chord, a line which is touching 2 points of a circumference here and here. It's called a chord. Even a diameter, it is also a chord, because a diameter passes or cuts the circle in between and it touches the circumference at 2 points here and here. It's also a chord. When you've got a tangent line, this is a tangent line, and this other one is also a tangent line, such that there is a chord which is touching both of the tangent lines. So what it means that the angle which is here and the angle which is over here are the same. So these two angles are the same. So the triangle which is formed now here, this is an isosceles triangle. So you can see that it's an isosceles triangle over here. Okay. All right. So now let's check the advanced stuff which we need to know. So this is we'll call it property number 1. So this property says that angle in a semicircle is 90 degrees. So the angle which is somewhere here, this is 90 degrees. If you can see, the circle has been cut by this line, and this is a semicircle up here. So the angle which will be formed up here inside the triangle will be 90. Even this side, it also be 90. Even if it was formed somewhere here, it could have been 90 degrees for as long as it's inside the semicircle. Let's check out this one. Angle at the circumference is half the angle at the center. So what we mean here, this angle, if this is 40 degrees at the center, this is O, center, okay? Meaning this one up here will be 20 degrees. This one will be 20 degrees. This is what the statement says. For as long as they are coming from the same chord, this chord over here, okay? And this one goes to the center, the other one to the circumference. The one which is at the circumference is half of the one which is at the center. So this is important. Let's go to another one. We'll call this one property number 3. So for this one, it says the angle in the same segment from a common chord are equal. So if you can see this chord over here, and there's an angle which is formed somewhere here, up here. So the angle which is here is equal to the angle which is over here, because they are coming from the same segment, this segment over here. So we need to know that these two angles are equal. If this is 50, this is also 50 degrees. Another one, okay, so this one we'll call it property number 4. What it says the opposite angle in a cyclic quadrilateral always add up to 180. So what it means this angle plus this angle, they're supposed to give you 180 degrees. Also this one and this one, since they are opposite, they're supposed to give you 180 degrees. If this is 40 degrees, what is this? What is angle x? Angle x will be equal to 140 degrees. We just say 180 degrees minus 40 degrees, which will give us 140 degrees. So this is how you find this angle. If this was 60, what is this angle? It will be 180 minus 60, okay, which will give us 120 degrees. Let's go to the next one. This is property number 5. The angle between a radius and a tangent line is 90 degrees. So meaning this angle here, this is a radius, this angle here is 90 degrees because this is a tangent, 90 degrees. Also this one is 90 degrees. This is what we need to know. Let's go to another one. This one reads, the angle between the chord and the tangent is equal to the opposite angle inside the triangle. Okay, so meaning this angle here, okay, the angle which is here, this angle is the same as the angle which is inside. You see this chord over here and the tangent line. So the angle which is formed here is equal to the angle which is somewhere here. So you see the chord, the angle which is forming is equal to the angle which is between the chord and the tangent. Okay, so we come to this one. So this angle over here, you see this, it will be equal to this angle here. If this is 20 degrees, this will be also 20 degrees. If this is 50 degrees, this will be also 50 degrees. This is what it means. So now let's try to answer some exam questions and use these properties. So this question came in 2019. The question reads, in the diagram below, A, B, C, D are points on the circumference of the circle. Center O, this is center O, okay, over here. Angle D, AT is 40 degrees. This is 40 degrees. Angle BDC is 30 degrees. This is 30 degrees. And AT is a tangent to the circle at A. So this is a tangent line, if you can see nicely. So the first question here, they're saying find angle CBD. So CB, where is C here? BD. It's over here. So they want us to find this angle here. So what property are we going to use in order for us to find this angle? Okay, what property are we going to use? So let's check among the properties. So we're going to use this property here. You see, this is a property that we're going to use, which says angle in a semicircle is 90 degrees. This is a property we're going to use. So in order for us to find this angle, we'll say this angle here is 90 degrees because this is passing at the center, okay, and this is 90. So we will say 90 degrees plus 30 degrees. Another property is angles inside the triangle add up to 180. So this property here, okay, so we're going to use also this property. So say 90 plus 30 will give us 120 degrees. So we have 120. So we know that all the angles, when we add them inside the triangle, this plus this angle plus this, they're supposed to give us 180. So we say 180 degrees minus 120 degrees, and this will give us 60 degrees, meaning the angle here is 60 degrees. This angle is 60 degrees, such that when we say 60 plus 30 plus 90, it will give us 180 degrees. We go to the next question. The next question here, they want us to find angle BAC. So BAC, they want us to find this angle here. So how do we find that angle? What are we going to use in order for us to find that angle? Sorry, not BS, not B, it's supposed to be BAC, not D. It's this angle. This is the angle we are looking for, not this one, okay? So we are looking for this angle. So how do we find that angle? So in order for us to find this angle, we need to use the property of angles coming from the same segment. So let me show you the property that we are going to use. We use this property over here, this property. You see, the angles coming from the same segment. So here and here, they are the same. These are the same because they are coming from this chord here. So if you can see nicely, we have got a chord here, this chord. There is an angle, the 30 here, and this. So this is also 30 degrees. So what we found is 30 degrees here. We go to the next question where they want us to find angle AOB. So they want us to find this angle here. So how do we find this angle? What property or which property are we supposed to use here? So in order for us to find this angle, we are going to use the property over here. This property here. Okay? You see, this angle between the chord and the tangent is the same as the angle which is inside here. The angle which is formed by this chord inside. Okay? So if you can see nicely, we have this 40 here. Okay? So this angle here, this chord over here has formed an angle up here. And this angle is between the tangent and the chord is 40. So this is also 40 degrees here, 40 degrees. So since we've got this 40 degrees, we can use another property here. You need to know the property because most time and time you'll be applying the properties. So we need to use the property which is over here, this property here, which says that this angle at the circumference is twice this one is twice the one which is at the circumference, or is half of the angle which is at the center, sorry, half of the angle which is at the center. So that's what it means. So this property, it will apply here. We have 40 here and this is the center, so meaning here it's 80 degrees. This one here is 80 degrees because they are all coming from this chord, this, and then another one, this. They are coming from the same chord. So this is also 80 degrees. So since we have found this 80 degrees and they want us to find the angle which is over here, what are we going to use? So we will say this property should apply of a straight line. So if you can see, this is a straight line, okay? And they have given us this angle. So can you fail to find this angle? No. We'll just say 180 degrees minus 80 degrees, which is equal to 100 degrees. So meaning the angle we just found here is 100 degrees. So these are the solutions. We go to the next question. This question came in, I think it's July 2019. Okay, so they're saying in the diagram below, A, B, C, D, and E are points on the circumference. So A is supposed to be here, B, C, D, and E here. So this is how it's supposed to be. Of the circle with center O. So the center O is here. This is center O. Okay, so the first question here, they're saying find angle ADE. ADE. So what property are we going to use here? You see, you just have to know these properties. So we're going to use this property here, which says this angle is twice the angle which is at the center, for as long as they're coming from the same chord. So they have given us the one which is at the center here. So how do we find the one which is up there? So we just say 80 degrees divided by 2, okay, which is equal to 40 degrees, because this angle is 40 and is twice the one which is here. So if we write that this is 40 degrees, meaning this should be twice this. Of course, it's true. So it's 40 times 2 is 80. Okay, so we've just found that angle to be 40 degrees. So we check another angle. Another angle here is DAE. They want us to find this angle here. And we forgot something here. They want us to find this angle. So looking at this triangle here, because of these signs I've just put here, on the diagram they are there. I think we just forgot to put them here. So these signs shows that or show that what we are dealing with is an isosceles triangle. So what we're going to do is to say the angle which is here and here are the same, are equal. Okay, so the angle which is here and here, they are the same, meaning we're dealing with an isosceles triangle. So we're going to say 180, because the angle which is here and here and here, they're supposed to give you 180. We say minus 40, and it will give us 140 degrees. So meaning these two angles, they have given us 140 degrees. So what we're going to do next will be to find each of them. What are they? So for us to find each of them, we'll say 140 divided by 2. 140 degrees divided by 2, which is 70 degrees. So meaning the angle which is here is 70 degrees. This is 70 degrees, and this is also 70 degrees. So let's check the last one. The last one here, they want us to find the angle B. What is B? It's over here. A and D. So they want us to find this angle over here. So how do we find that angle? We know that this angle is 20 degrees. By now we should know that it's 20 degrees. What property have I used? I've used the property of angles coming from the same segment, this one. So if you can see, this and this are the same. This is the property I've used. So here, if you can see this chord here, this is a chord. There's a triangle or an angle which has formed here, okay, and another angle up here. So meaning this angle and this are the same because they are coming from the same chord here. So they are all 20 degrees angles. So we have this, we need this one. How do we find this one? So for us to find that one, we're going to use this property here. This property is the one we're going to use. Opposite angles add up to 180 degrees. So we will say this angle is opposite over this angle here. Is opposite to this, or opposite of this angle. If you can see this one. So this is this one. So we say 180 degrees minus 70 degrees. This 70 degrees. We are using the property of opposite angles, which will give us 110 degrees. So we have found this one to be 110 degrees. This one's 110. So since we have found 110 and we have 3 angles, this and this, we can add them and subtract from 180. We remain with this one. So we'll say 20 degrees, which is this one. We want to use the property of angles inside the triangle. If we add this plus this plus this, are supposed to give us 180. So we'll say 20 plus 110. What are we going to get when we add? We'll get 130 degrees when we add these two. So since we've added them, so for us to find this, we use property of a triangle, which is 180 minus 130 degrees, which is equal to 50 degrees. So our answer here is 50 degrees. Kindly subscribe to my YouTube channel and also join our online tuitions. We are offering online tuitions in mathematics, English, science, biology, and RE. So the number to use is 0969175701. This is a WhatsApp number we are using. So for those who are not in Zambia, you can put our code, which is 20 plus 26. Okay, this is the code.